Now, I want everyone to take this with a grain of salt. Like, don't come lynch mobbing me after because you love your spas, but this is the general experience you have. Like, you go to a website. I'm going to go to my conference talk website and click on it on Google, and then I get a white page and sit there. No, something's happened. We're good? Oh, we're there, okay? So I think the Twitter or X app is now up to 7 nested loading spinners or something ridiculous. This is one of the downsides of spas. There's certainly upsides, and we're going to be talking about both. This isn't just going to be a spa bashing session, but it should be a little bit of fun just exploring how we got here, why did we make the choices that we did, and kind of what are the trade-offs we've been making. So we'll be going through a bunch of those things. Keen to hear everyone's thoughts afterwards, what your experiences are. It's an area that I really do care a lot about. So a bit about myself. I also work for Arkahna, if you were in this room for the last session with Lars, another principal consultant there. My focus is really around our internal products, bit of technology direction, that sort of stuff. But previous to Arkahna, I worked at the West Australian. So me and my team, we built the west.com.au, Perth Now, and 7news.com.au. So that was probably about, I don't know, 7 years or so that we started that. And the West and those websites are server-side rendered React applications. So 7 years ago, probably quite a modern, risky tech stack to go with. And it was very interesting. At the time, there was no Next.js or any other of these frameworks, so we learned how to build all of this from the ground up. It was a very interesting time. I've got all my socials up there. I'll put them up there at the end as well, so you can follow along or give me feedback or give me your anecdotes and whatnot. The little character, Arkahna commissioned little D&D-based characters from someone who does D&D art in the States, so we all got our own little characters, which is really, really cool. D&D and ice hockey are probably my 2 favorite pastimes, so good fun. I just want to say thank you for all of our sponsors. They, like, literally DDD couldn't happen without them. It's not a cliche. They make up the fact that this conference, like, they're expensive to run, and without our sponsors, we wouldn't be able to do nearly what we do today and make it a really good day. So just thank you to all of them. Okay, so this is the general journey I wanted to kind of take you on. We started with multi-page applications where you have ASP.NET Core, your traditional PHP style apps that are just request response. We moved to progressively enhancing them with JavaScript and improving those experiences, making them a bit more app-like. We then kind of jumped ship and moved to Spa, where we just said, go away server, I'll just call my APIs. And then there's been a lot of evolution and around what's actually coming next. So I want to take you along the journey, fill in some gaps, hopefully, of what happened and some of the trade-offs or reasons that we jumped forward or made these changes. So we'll start with multi-page applications, traditional web apps. Just before I get started, who here uses kind of a more traditional PHP, Django, one of those? Like, what's the, cool? Who's building a single page application? Most of the room. This is going to be good fun. So for those who are newer to the industry, you might never have done a lot of these older architectures. So I'm going to fill in some gaps for you. So we've got a website here. I go to website.com. The contrast there is not amazing, so sorry about that. So website.com, we do a GET request to the web server, and it returns me a full HTML document of the page. The web was built to share documents. That's kind of its origins. It has something called hypermedia, where I can click a link and it takes me to the next page. That is a full round trip to the server. We throw away the old page and we load the new one. So new request, get a whole new document, and then the old document is replaced. So nothing is transferred between those 2 pages. Browsers have got much better at this. Previously, it used to click on a link, white screen, then you get the new one. They now kind of keep the old one there while the new one's loading, but that's the experience. Now, once people started playing around with that, JavaScript originally was kind of used just to do little hovers, so change some images on hover, or do a little bit of client-side form validation. There wasn't a lot. That was what JavaScript was built for, just simple interactions, improving the static kind of document-based model. Then started playing around with dynamic HTML, like nav links where you can click, expand the nav. All this stuff is just, we take it for granted. That is what the web is today, but these were quite big leaps at the time. Drop-downs, and also like dynamically and showing and hiding bits of a form based on previous inputs. That was kind of dynamic HTML. And the main part about this is manipulating the DOM without talking to the server. We then got into Ajax. Don't worry, this is not going to be an entire history lesson. I just want to quickly fill these things in. We would make a call, fetch some data from the server. Yes, it originally was XML. We'd use the DOM APIs or XML APIs to parse that. But we would hit the server, get some XML, use that XML to update our page in place. So there was some pretty, at the time, this was quite amazing. We started building apps on the web. What it looks like, though, is I'm going to separate the client and the server so we can see kind of what's happening where. Same as before, make a request, get a full document, but I also have some JavaScript. The browser will go grab that script tag, and it will have some JavaScript functions. There'll be global functions. Then when a user interacts, clicks a button or whatever, it will call that function, which can then use the XML fetch APIs, and go grab some XML, bring that back, and then your JavaScript can use that and patch the DOM. Now we have a new version of the website. This is kind of the slowly making the pages a bit more enhanced. jQuery was big at this time because the browsers were all inconsistent, like the same code would work differently in different browsers. It was a bit of a pain. So those that were in the industry at the time, this will be bringing back bad memories. jQuery was this amazing thing that kind of normalized all of the browser inconsistencies and made it much easier to do this. So that was kind of the age of progressive enhancement where you could turn JavaScript off and the web still worked. That's because plenty of browsers just had terrible JavaScript engines and whatnot. So it was really important to target the lowest common denominator. As front-end devs do, we go grab a bit more JavaScript and just keep going and take things way, way too far. So Gartner have this hype curve, they call it, the Gartner hype curve. And there's normally like a technology trigger. We're going to talk about Ajax, and it was kind of the start, and we just kept putting more and more JavaScript. So a lot of looking at what was possible now that we'd kind of cracked this new technology. And people were starting to ask, could the web actually be an application platform rather than like just a document like discovery platform? At the time, really, if you were a business and you had an application that you wanted to give people, it was really a desktop application that they had to download and install, and that had a lot of problems. But browsers were becoming far, far more capable. We had the ability to improve interactions and make these web apps a bit more app-like and improve the user experience. The users didn't need to install anything, which was a massive saving. And you could also update it. So this was kind of a real big innovation. People started going, the web could actually be really good for our internal line of business apps or all these other scenarios. So what that looks like is, it brought a problem because the JavaScript became more and more app-like, had to render more HTML. And what you ended up having was two applications in the one. So application one was quite, what's happening? 2 seconds, there we go. So your application one was normally written in some sort of back-end language like PHP, C# using frameworks like ASP.NET, MVC or Django or one of these sort of back-end frameworks. It has form validation logic because you have to validate your forms on the server. You can't just trust what the client is sending you. It renders HTML. They all had their own view engines. And then we had another application. This was the JavaScript application. It also had form validation logic because you had to give a really nice user experience. So you'd often have to write that twice. There were code gen approaches where these backend frameworks would generate JavaScript for you, but in essence, it was there twice. But the real problem with this model is that application 2 is changing the HTML that was rendered by application 1. Now that is a form of coupling of the two bit applications together that's normally quite brittle. And there's not really any other part in software development that has this sort of coupling between two applications and it's considered good practice. So that's kind of the issue that was starting to emerge as we started pushing progressive enhancement more and more. So let's just look at some of the trade-offs, pros and cons of where we're at. So this approach has a really fast page load. You can leverage HTTP caching. The browser and the platform is actually a really capable platform of doing a lot. Heaps of heavy lifting, lots of features, very well thought out. It's a very powerful platform. You can use whatever language and technology you want. It's run on the server. It just needs to produce HTML and JavaScript and CSS. It's stateless. This is one of the best things about this request response style is the browser would issue the request and it would issue a response. All of those requests are stateless. You then can have sessions and put that state, but your server and application doesn't have to worry about mutating state over time, which is a really, really powerful thing. And then we can progressively enhance that with JavaScript. Downsides, 2 apps instead of 1. That's probably the biggest downside. Navigation can be slow. Every time I click a link, if the pages are big, I have to go back to the server, download all of that. It's fine on our really, really quick internet connections, but on slower ones, it can take a while. The other real big problem, which is a massive issue on news websites, and none of you would hit this problem because everyone in this room would use ad blockers, but most ad frameworks are absolutely awful. Analytics and third-party ad tracking. As an example, at the West, we used a modern tech stack, React, and server-side rendering and whatnot, doing some profiling, trying to understand what's happening with the ad blocker off, and we had 5 copies of jQuery, all different versions running on our page that we didn't use jQuery at all. All of those were loaded in by various ads and third-party scripts. So if the old multi-page application, all of that third-party code had to be parsed, re-downloaded, often cached, but parsed by the browser again can be really expensive. So there's quite some heavy downsides of these, even though there's a lot of upsides. So some smart people decided, hey, why don't we just get rid of the server? There was no HTML5 push history APIs at the time, so it came up with hash bangs where you would put essentially what the location is into a fragment on the end of the URL, and that allowed us to emulate the browser experience using JavaScript. Early versions of this were just a whole bunch of if-else statements. If the fragment matches this, then render this bit of page. But it essentially were the early incantations of single-page applications. It evolved over time, but that's where we kind of started. This is where we kind of split between having web applications, which are more about functionality, not information. And then you've still got websites. So we started a bit of a parallel stream. This was really good for internal enterprise applications. For instance, your IT department didn't need to push out software. You could just build these web apps. So it was really, really quite good. So SPAs are excellent in this space. What does that look like? With our website, we make HTTP GET. Difference here is I've just got a static file server that serves an index.html. That goes back. All of that file contains is a little bit of metadata, but the main thing is it's got a script tag in it. That is our application, and there is nothing rendered. That's where you get the white page. It goes and fetches that JavaScript file, and then that JavaScript file renders your application into the page. So this is kind of how this works. This is the point you get the spinner, because you now have loaded your JavaScript application, but it has no data. It needs to go get the data. So it makes an API call to the server, grabs the data from your web server, and then it can finally render the page. If you've done any sort of web performance tools or had a look at the network tab in your Chrome browser, or if you're on Mac, I highly suggest Arc, it's awesome. What you'll see is the HTML gets fetched first, then you go get the JavaScript. Each of these things are done one after the other. They can't be run in parallel. Then the JavaScript goes and fetches the data, and finally the user gets to see what they want. Now, for web applications, which are internal for a company, that really doesn't matter, right? You're hitting a login screen. You're used to booting up a desktop application. It could be local to the network. It doesn't really matter. But for web, like let's say it's a Amazon or some other site, that there is blurring the lines of, is it a web application or is it actually a website? Because I'm browsing for different items. I need to get information, and it's well proven that if I can't access that information quickly, then I'm likely to bounce. So these waterfalls for especially e-commerce sites and whatnot are really, really important. Let's have a look at the opposite. We've got the HTML for, in reality, what ends up happening is there's not just one API call. I need to go fetch the data of the currently logged in user. Then it goes and grabs some information around the shell. This is like the Twitter example of, okay, now what sort of page am I on? Now I'll go fetch the data for that page. So there's this big waterfall of all of these nested API calls. And then finally, we can see what is loaded. So this is what causes this spinners and kind of the progressive loading. There's another real big problem with this. JavaScript is terrible for building large applications as a platform. The language wasn't designed to it. If we go back to kind of the origins of JavaScript, it was trying to just create a little bit of interactivity within web pages. That was the initial design, and now we're building full-blown web apps in it. It just wasn't built for that. So what do JavaScript developers do? They create. This kind of was the start of a huge amount of tooling and innovation in the JavaScript space. While really excited because we were rebuilding and solving all of these problems, the learning curve, because there were constantly new tools, was really, really big. As an example, here are some of the problems that we had to re-solve. Client-side routing, I talked about the hash bang and being switches to load the routes. This is a complex problem. We want to make sure it's handled well and our applications can handle that kind of complexity. We had routing on the server. Now we needed it on the client. Auth. Session-based auth was really, really simple. Now we've got to deal with JWTs and OAuth flows that have no secrets. Those sort of things make auth really challenging, and that was a whole bunch of auth providers like Auth0 and whatnot were born out of the complexity that came with auth with single-page apps. State management around client-side state management. When React came, there was Flux and all of the Redux libraries and all these ways to manage state, because something that creates complexity is if you have state and it changes over time, that will create complexity in your app. So we needed tools that allowed us to combat that. Code splitting, by its nature, it's a single-page application. It has the entire application's code, all of those multiple pages, in a single app. That just means that we ship a huge amount of JavaScript to the client. So we had to create build tools that allowed us to split that up and chunk up different parts of the code. So code could be dynamically loaded as it's needed by your application. Scroll restoration. Who has clicked back on a single-page app and then it chunks in and then jumps down to the bottom? That took me a long time to make sure that wasn't awful at the West, and with varying degrees of success because ad tech. But it's actually a really hard problem that the browser just solves with multi-page applications. Data fetching and caching. What do they say about computer science? The hardest 3 problems, or 2 problems, are off by 1 errors, cache invalidation, and that's it, isn't it? Navigation progress indication. You get a, when you click a link, browser shows you you're navigating. Offline access. We had HTTP caching. If you set it up correctly, you could not be on the internet and it would continue being able to serve pages that were in your local cache. There are all of these problems that you had to resolve, which makes it really, really hard. And finally, my favorite, if I'm working in a React app, is form management. I can't tell you how many JavaScript form libraries I've used over the years trying to make it, and recently I've gone back to a framework, which we'll talk about later. It's not a framework talk. And I forgot how simple HTTP forms are. The web had solved these problems that we just reinvented and made them way harder. So there's a lot of problems that we need to resolve. We then kind of got into this where you just couldn't keep up. This one's quite good. There's plenty of them. It was a hard choice. But this is the point that I think where we went wrong. We started making websites single-page applications. We've talked about the difference between web applications and websites. This is the area that I really struggle with because the web is a good platform. It's accessible, has all of these things, and now we're having to resolve these problems, throw away a huge amount of investment in quite a mature and powerful platform. As I said, doesn't really matter for internal apps. If you're hitting a login screen, don't really need any of that stuff. But for websites, it kind of does. I also lied earlier when I showed the Google search result. If it was a spa, this is actually what you'd get. There's no content. It's an empty page. Generally, spas are bad for the web as general. In terms of a platform, that's where I think we're going wrong. But they are really, really good for some things. So let's have a quick look at kind of the tally sheet of spas. Single code base rather than the 2 code bases. Has really fast app-like navigation. I click, immediately goes to the next page. We've got really cool tooling around prefetching, so it will automatically load the data for the next page. The app-like experiences is a huge one. We're now actually using the web platform to build desktop applications. Like VS Code is a web application that a lot of developers use. It's really good. It shows the power of what the web platform can achieve instead of desktop applications. Elements can persist over pages. So if I've got media playing, I can navigate around the site and keep playing a podcast or picture-in-picture video or whatever the scenario is. We are now finally getting some transition APIs built into the platform that allow you to have a multi-page app that keeps elements over page navigations, which is really cool, but you'll never be able to match what a single page application can do in that space. We've got really, really good client-side state management, which gives us libraries that deal with the caching and validation and a whole bunch of other problems are kind of taken care. So there's some really, really amazing libraries that make all these problems I talked about earlier kind of go away for you. Downside is complexity. You might not realize it, but we talked about state changes over time. They are complicated. They are hard to debug. The number of times that I've accidentally messed up my dependency array in a use effect and my page just continually crashes because I forgot to memorize some function or something. It's really complicated. The amount of base knowledge you need to play in this space is really high. The build tooling is complicated. There's so many things that you have to understand. So much harder than just being able to spin up a web server that can serve some HTML. So that's one of the major trade-offs there. Huge amounts of JavaScript slows down the web. Not everyone has iPhone 15s and these amazing processors that can parse 10 meg of JavaScript and not worry about it without melting. But this is generally bad for the web. It's bad for accessibility, and a lot of us, parts of the world, don't have all of these affordances that we have. So JavaScript Too much of it is a really, really bad thing. And generally, it's less accessible. The platform, the web platform, is a very accessible platform, and we kind of take that away, and we've had to rebuild a lot of those accessibility features. And we've seen the slow initial load. It's also just generally less resilient. We kind of think that all of these HTTP calls are going to succeed. They don't. Like, there is a huge amount of failure in the web. That's why the platform is so good. It has failure built into the web platform. It expects failure, and it knows how to recover. Single-page applications don't without engineering effort. So we've talked about multi-page applications and single-page applications. What's next? What can we do to make this a little bit better? So a couple of options. One of the contenders out there, and I'm going to talk about some specific frameworks, but there are, what I want to kind of explain is the techniques that are coming out, and this is not an exhaustive list. So something that's quite popular is something called Hotwire. The Rails community is using this. There are different options depending on your stack, but I just realized my mouse cursor was in that. Sorry, everyone. Now I've pointed it out, everyone will notice. So Hotwire, the idea of it is that you have your server, and the server ships a bit of JavaScript, but what it knows how to do is update that HTML. So you just send snippets of fragments from your server, and it dynamically updates it. So the GitHub UI is a really good example of this technique. The problem with this technique is now you've got distributed state. You don't have a single store of state. What's the problem, you say? Who has closed a GitHub issue? You've got one issue, you close it. How many issues are open on the Issues tab? Still says 1. Refresh. Now there's 0. It is really, really hard if you don't have a single source of truth to keep state synced across your entire UI. The number of times I've seen, like, I've merged a pull request and it still has the open pull request at the top, but it says it's merged down the bottom. You can fix it, it just requires a heap of engineering effort. Hotwire and similar frameworks, they're designed to make that easier, a bit more automated, but you still have the issue of, I need to call my server for every interaction to get things. So I don't know, it's a pretty cool technique, and it's good that people are going, but I'm not 100% sure. The road that I've spent a lot of time is the universal JavaScript applications, where I write my applications in JavaScript and I can render them on the server. So single server-side rendering has been around for a while. Essentially what that means is this is a little bit of snippet of React. I have a React form component. You can see that when I click the submit button, I haven't showed the whole thing, but I've got a busy bit of state that says that I'm currently busy, and it changes my button to a creating text. Now, if I render this on the server, busy will be set to false. It will render all of this HTML saying create new project. Once the client starts up, click the button, it reacts. It's kind of this nice blend between the two. This is what universal JavaScript is designed. One application that blends between the client and the server. I really like, there's no real formal term for these types of applications. One of my favorite ones that I've seen is transitional web apps. It's from this talk by Rich Harris. He worked at the New York Times, now works for Vercel, and he's got this talk, Have Single-Paged Applications Ruined the Web? It's another great talk, so go have a look at that. But he coined this term, or tried to coin this term around, called transitional web apps, and he got it from interior design, where you have traditional design and then you have modern design. Each have good elements. Some people like the older, some people like the newer. Transitional design is trying to take elements from both to create something in the middle that takes some of the best aspects of both. So I like the idea. There's a couple of these frameworks out there. So Remix is one that kind of started pushing the boundaries, where when they first announced it, it was being demoed, and they were demoing this new JavaScript framework, and people were like, oh, that's pretty cool. And then he's like, oh, by the way, the last 5 minutes I've had JavaScript turned off in the browser. And so I turned it back on and then did the same demo, and there was like instant navigation, loading spinners. The whole application just became a lot more app-like as soon as he turned JavaScript on. I've had similar things where I broke the application and I was testing and didn't realize for about half a day that my front end was crashing as soon as it started. It had just fallen back to server-side rendering and being a traditional web app. I didn't really notice. So it's that idea of progressive enhancement. In the .NET space, Blazor is doing very, very similar things. So Remix and Blazor are quite similar architectures, solving similar problems. But instead of it all being written in JavaScript, you can write it in C#, and Blazor compiles it to WebAssembly, which can run in the browser. So other communities like Rust and whatnot are working on this similar kind of transitional web app, but the main requirement is the client can run in the browser. So you can write code that can run both on the client and the server, and WebAssembly is a way to do that. And then SvelteKit's another. So there's a bunch of these different ones. As I said, I'm not going to go into framework specifics, but this is kind of the area that we've started seeing these transitional web apps starting to appear. Let's have a look here at our diagram. So when I load the website, notice the web server is back in there. This is very multi-page application-esque. What it does on the back end is it will call my APIs, call my database, however you do it. It fetches the data, and then it renders the page, similar to a server-side rendered application or a traditional web app. So you get your content. So immediately, the content is returned from the server, and also the data as well. But I'm not going to go into those sort of details. And then you have your JavaScript single-page application kind of thing as well. You click on a link to /page, the framework will know how to talk to the back end. So it will go make an API call. You don't have to write this API. The framework will just expose your back end data loading functions to the front end and transparently call them for you. That will just fetch the data. Now, if you refresh the page, it will go back to the first one, and it will be the same data loading function that was called via an API has now been called within the server transparently. It returns the data, and now I have the next page rendered. It's rendered like a single page application. There's a lot more complexity here. Like they automatically do code splitting and a whole bunch of really nice things. So they will take care of loading the JavaScript that's required for that next page, exposing, am I currently navigating, all of these really annoying problems. We've started, rather than having a million different libraries that solve all of these individual problems, transitional web apps are starting to settle on, okay, we've spent the last 10 years experimenting on different ways to solve these problems. We now know how to solve them. Let's start standardizing and putting them into these frameworks so developers don't have to continue making all of these decisions to be productive again. Start leaning back on the platform. When I submit a form, it once again makes a transparent API call. I don't have to write that API. My backend can now make further APIs, however it does it. And then I get a HTTP redirect, which is how multi-page applications, when you do a post, they have to say, where do you go after the post? So this is kind of, the model is starting to look very, very similar to what we had with transitional web apps, except I'm returning data. So we're getting this like nice little blend. What happens if I turn JavaScript off? Let's go through the same thing again. First one, exactly the same. We get a server-side render. The second one, when I navigate, it will just be a normal HTTP get. The browser will navigate to that next page, and it will be a full page load. This also happens if the user clicks on a link before the single page application has started. Because if it's a React app and it hasn't booted and you click on a link, it doesn't do anything because there's no click handlers yet to handle that navigation. So this is just a traditional web app until all the JavaScript loads and it's progressively enhanced. Render the page, fetch the data, render the page, return page 2. Same thing with a form. I do a normal HTTP post when I submit that form to the server. it can handle that post, update data, and then it will redirect to wherever I have to go afterwards. So that's kind of we're now starting to get this blend between the two. If we have a look at our trusty little waterfall diagram again, we get the HTML and data immediately. The users can see what they want to do. If it's an e-commerce website, they see the product immediately. They can decide, start reading the description of that product. Then all the app-like features come in, and I can click Add to Cart, and it adds to the cart. The number increments because there's a single source of state, and I can kind of start getting the best of both worlds. My JavaScript then just comes in, and the application is all good to go. So you start removing some of those negatives. The other real great thing about this direction between transitional web apps is it is based back on the platform, focusing on web standards and the basics that have been around for ages. The problem is we kind of forgot about these basics, and they're not needed for single-page applications because we have new techniques and approaches to solve similar problems. So these new generations of these single-page application frameworks, rather than having custom data loading APIs and a whole bunch of other things, they're focused on web standards and making sure that we can leverage the platform that's there and not have to reinvent the wheel. As I said, there was a lot of experimentation, finding new ways to do things. We've kind of learnt. Now the platform has adopted those, like the transition APIs in the browsers. We've taken the best parts and put them in the browsers themselves. So the platform itself has got better. So the transitional web is built on HTTP, fetch APIs. So fetch is now a browser standard. There is no need to have custom libraries like Axios and whatnot. We've got a standard on the client and the server. Forms, go back to standard progressively enhanced HTTP forms. We've got cookies, so we can go back to like traditional auth approaches, putting stuff in a session cookie. It is so liberating going back to that. You forget how simple it is. HTTP links, hypermedia, progressive enhancement. All these things are really, really good for the web. They keep our applications simple, and then we can reach towards those capabilities of single-page applications when we need them. So if we have a look, the transitional web has fast page load time. It can leverage HTTP caching. The browser and the platform start doing the heavy lifting for us again. You can use whatever technology you want, as long as it compiles to WebAssembly. Stateless, the model is generally stateless unless you decide that page has interactivity and needs to be stateful. You can progressively enhance it with JavaScript to have client-side state and rich interactions and all of these cool things that you could do with single-page applications. These were the issues that were there, so we're getting rid of those. If we're having a look at the single-page application, we have a single code base, fast navigation, app-like experiences, elements that can persist over pages, client-side state management. These are the things that we could do. They were more complicated, too much JavaScript, less accessible than the one on the left, slower page time, load time, and they were less resilient in general. If the browser didn't have the right version of JavaScript, or the JavaScript file crashed, for instance, like ad blockers. This was something that constantly happened with us. We got intermingled with third-party code. It assumed the ad blocker wouldn't block these scripts. It's calling JavaScript that's not there. The whole page crashes. It takes a lot of engineering effort to make sure you're resilient to something that I expected to be there just isn't there. So there's all of these downsides, but by adopting transitional web apps, we can kind of get rid of all of these negatives because we're taking the best of both and trying to solve for the best of them, really. So the takeaway is, please give transitional web apps a go. There's a couple of different ones, Remix, Blazor, Next.js with React Server components and the app router is definitely moving this way. They're adopting more of these standards. The downside of, the challenge they have is they were one of the front runners. So they invented solutions to all these problems. They have a massive code base and now need to migrate everyone towards these more modern approaches. So they're definitely doing that. I have been having a great time with Remix, but your mileage may vary. But try them out. I do highly recommend giving Remix a go. It is a phenomenal web framework that is really, really simple and well thought out. It's surprised me many times, considering I built very similar things to these frameworks while I was at WA News. I was quite impressed at some of the solutions to the problems that they came up with. So that was single-page applications. Where did it go wrong? I hope that was educational, filled in a little bit of history. Does anyone have any questions before I wrap up? I've got a couple of minutes.
This might be a question that I'll go away and try and answer myself later, but taking advantage of HTTP caching with the transitional web apps approach, we can do that now because it's going to render the HTML document, send it back, the browser's going to cache that document. Later, if we try to view it, it's going to get it from the cache instead. But after that, if JavaScript's running, rather than pulling back a whole HTML document, the next step when we navigate is going to use JavaScript to alter the page and make API calls in the background. So do you know, and this might be a difficult question, is it built to update the HTTP cache with these kind of synthesized HTML documents?
It's a great question. Yes and no. So what it can do is cache each of those responses, and frameworks will automatically, as soon as there is a mutation, they will go refetch the data for all of the loaders or data around them. The issue is if you have set HTTP caching headers on some of those responses, they can't invalidate the browser's cache. So if you are going to use mutations to change, to change data, make sure that you use headers to last modified and those sort of things, e-tags, something like that can invalidate the cache that you're going to go back, so the server can ignore the fact that it has or the browser can ignore the fact that it has a cache response.
I think we've got time for one last question. Hands up. All right, we'll go over here.
Thank you. That was a good session. I have a very simple question. Where does micro front end sit in this whole ecosystem?
So the question is, where do micro front ends sit in the whole ecosystem? It's a good question in respect to good architecture around if you have different teams or different people updating a single web app, micro front ends allow you to break apart your application and have different versions of dependencies that different teams can own in a single cohesive web app. So I think that architectural decision is separate to if you're going transitional or SPA or multi-page application, because it's more about your organizational challenges and do you have issues with multiple teams trying to update the one app and them having conflicts or different release cadences or those sort of things. So micro frontends definitely solves a problem, but it is, in my mind, a different problem. So hopefully that answers the question.